In this video, we are going to find the value of the derivative of the present value of a bond position. And then we're going to estimate, using differentials, how much money we make or lose if the yield changes. Okay, so we've got some formulas we need here. First, the present value. So the present value of a zero coupon bond is n, the principal, times 1 plus y over 2 to the power negative 2t. Again, we're looking at semi-annual yields. We can take the derivative of this function. We take the derivative using the power rule and the chain rule. So that's the derivative, PV prime of y, is negative t times n times 1 plus y over 2 to the power negative 2t minus 1. And then remember, with differentials, we have dPV equals PV prime of y times dy. So that's how we estimate the change in the present value. I'm going to do this problem in Excel because it's a little bit easier to set up and do the calculations. You're more than welcome to use your calculator as well. So let's set this up. We've got today, we've got the principal, we've got the maturity, and we've got our semi-annual yield. So, and then what are we trying to calculate? We're trying to calculate PV prime of y, and then we're trying to calculate dPV. Okay, so let's just get some formatting right. Set these up as headings. These are all inputs. These two are outputs. Today and maturity, I'm going to format Control 1, tab, date, tab. So we'll set up with my favorite date format. So this is 6/14/2021. The maturity is 8/3/2024. The principal is $250,000. The semi-annual yield is 3%. Let's change the formatting here. There we go. Okay, so the derivative, plugging in the semi-annual yield and all the rest of the information in, we get negative t. T is maturity minus today divided by 365, so that's negative t, times the principal, times 1 plus the yield divided by 2 to the power. Negative 2 times t, we've got to do the calculation again. B3 minus B1 divided by 365 minus 1. So there's PV prime, so negative 704,308. Is not the most intuitive number out there. dPV, so that's PV prime times dy. The yield's going from 3 to 3.45%, so dy is 0.0045. In fact, let's do this. Let's cut this, put this down one, and we'll call this new semi-annual yield. Clearly this could be different as well, so make that heading 2. Let's just copy this down one, and we'll make this 3.45%. Okay, so we've got our last input there. dPV is PV prime times the change in yields, 0.45% or 0.0045, so negative $3,169.39. Again, let's look at these formulas for a second. Negative time, days over years, days over 365. So negative time times the principal times 1 plus the yield over 2 to the power negative 2t minus 1. And dPV is PV prime times the change in yields. So that's B5, the new yield, minus the old yield. And again, we'd expect this to be negative. When interest rates go up, bond prices go down.